Okay, this video is going to be about the plate tectonics explore assignment. In this assignment, you need to answer a question, what are plate tectonics, but you're also going to be taking notes, okay? You're going to be writing down the main idea for each passage and key details in your ELA notebook as well as unfamiliar terms, okay? So with this, and you're going to define these unfamiliar terms using vocabulary.com, okay? And you want also key details in this. Now we'll read this instructions all over again, but I want to preface this by saying that these notes that you take are going to directly lead into the explain plate tectonics assessment. Okay, so please make sure that you know that what you do here matters, and it matters because you want to score 100% on that assessment that's coming up next. So I'm going to go ahead and read this first section here, which is the directions. So in this task, you will read the text below, read one section at a time, and write down the main idea for each passage in your ELA notebook. Read the text for a second time and write down unfamiliar terms. Define unfamiliar terms, unknown words, using vocabulary.com. 4. Read the passage again and write down any important key details, okay? 5. Answer the question, what are plate tectonics? 6. Post the answer in the assignment submission. Typed. No photos, please. So when you're typing your answer, make sure you're using the ACE structure and that you are answering by rephrasing the question as a statement. You're providing clarification for that statement, and then you're fortifying that statement with some sort of textual evidence. Okay? The textual evidence in this case should come from the articles or the passages, excuse me. Let's go ahead and go over these passages. There are 1, 2, 3, 4, 5, and 6 passages total. And these passages, you can tell they're passages because they have these subheadings. So here's the main heading, plate tectonics, and the subheadings, okay? The subheadings equal a passage. I'm going to go ahead and read those now. And if you didn't quite understand the directions, I want you to pause and rewind and listen to the directions 1 or 2 more times until you fully understand it. If you don't understand the directions still after listening to them, go ahead and listen to me read, but then send me an email, or even better, head on over to our website, should already be on your favorites list, and then go down to Schoology, click the drop down, and since we're in science, you're going to click the science and then click parking lot. Then you can go ahead and fill out a form, Google form, of any question that you might have. If you can't get a hold of me through GoGuardian, for I'm not available because I'm with another student, go ahead and fill this out, okay? You need your name, first and last, and the date, okay? It'll give me your email, so don't worry about it. Rate the question's urgency. Is it really important? 3, is it not that important? 1, and then finally, what is the question? And then when you're done, you'll click submit and I'll get a copy of that. So if there is any questions after you've listened to the assignment description multiple times, please don't hesitate to go and message me using our question and answer parking lot message board. So I'm going to go ahead and start reading now. A land in motion. Although we think of the land on Earth as being fixed and stable, it turns out that it is constantly moving. This movement is way too slow for us to notice. However, because it only moves between 1 to 2 inches per year, it takes millions of years for the land to move a significant amount. So basically what's happening here is it's saying, we may think because I'm sitting here in this room, the floor is not moving from underneath me, but it turns out that even though we can't notice these movements because the movement is too slow for us to notice, almost like the rotation of the earth, right? The spinning we don't notice, okay, because it's happening too slowly for us to even understand. The rotation of the earth, okay, not the orbit around the sun, but the rotation of the earth takes 24 hours. So it is slowly moving little by little in that 24-hour period of time. That's the same for the land in motion that they're talking about. This movement is way too slow for us to notice because it only moves between 1 to 6 inches per year. So 1 to 6 inches per year. That's if you were to take inches and you were to say, okay, I have 365 days in the year and I have 6 inches. 6 divided by 365, that means it is roughly 2/100ths of an inch per year that it goes. 2/100ths of an inch. That's incredibly small. So it takes millions of years for the land to move any significant amount. The lithosphere. The part of the land that is moving is the Earth's crust, or the Earth's surface, called the lithosphere. The lithosphere is made up of the Earth's crust and a part of the upper mantle. The lithosphere moves in big chunks of land called tectonic plates. Some of these plates are huge and cover entire continents. Major and minor tectonic plates. Most of the Earth is covered by 7 major plates and another 8 or so minor plates. The 7 major plates include the African, Antarctic, Eurasian, North American, South American, India, Australian, and the Pacific plates. Some of the minor plates include the Arabian, Caribbean, Nazca, and Scotia plates. Here is a picture showing the major tectonic plates of the world. And you can see these little black lines are the different plates, okay, of our world. And then these arrows are showing whether the boundary lines are convergent, divergent, or transform, okay? So it is showing whether these are pulling away from each other, if the arrows are going opposite. So if we have in this Pacific plate and Nazca plate, you have literally these arrows that are drawing. They are showing that this boundary is divergent. It is pushing away from each other. Not likewise, but on the other token, if you look over here at the Pacific plate touching over at the North American plate, you see that these are convergent boundaries. These boundary lines are pushing together. So they are actually pushing up against each other. Then if we look over at some other boundaries, North American and on the Pacific plate, closer to Baja California, you see that there are transform plates. So they're actually gliding past each other here. So you see a plate here and a plate there, okay? And if I'm not mistaken, this transform plate line right across here is actually what makes the San Andreas fault line happen, because these are transform boundaries that are occurring. They're sliding against each other. That's why you can get a large amount of earthquake activity all around this area right here, because you can see, if we scroll up, we can actually see that these arrows are showing some pretty significant movement going one way and then the other plate going the other way. Continents and oceans. Tectonic plates are around 16.2 miles thick. There are 2 main types of tectonic plates: oceanic, write that down, and continental, write that down. There are 2 main types of plates. I would write this whole entire thing down. Oceanic. You want to define what it is. Oceanic plates consist of an oceanic crust called sima. Sima is made up primarily of silicon and magnesium, which is where it gets its name. So it's actually a combination of silicon, they drop the licon, and they add ma to it. So I think it's actually the 2 elemental signs from the periodic table put together to create this new term, sima. Continental. Continental plates consist of a continental crust called seal. Cl is made up of primary silicon and aluminum. Again, these are the two periodic table symbols for the elements silicon and aluminum, and they're put together to spell the new word, which is the substance that the continental plate is made up of, silicon and aluminum. So make sure you have these definitions down. I'm going to give you a hint. They're very important for taking the assessment. Plate boundaries. This is going to be really important for when you're doing your model in the, I believe it is the elaborate phase. You're going to be proposing what model you're going to be building. So plate boundaries. The movement of tectonic plates is most evident at the boundaries between the plates. There are three main types of boundaries. There's convergent boundaries. A convergent boundary is where two tectonic plates push together. Sometimes one plate will move under the other. This is called subduction. So when you have a plate moving underneath another one because they're pushing together, again, let me draw that out. Plates that are pushing towards each other. We saw this in the map. So when there's two boundary lines and you have them pushing together like you have in this picture here, what happens is when they push, one of the boundaries will start to go underneath the other, and that is called subduction. Okay, subduction. So although the movement is slow, convergent boundaries can be areas of geological activity such as the forming of mountains and volcanoes. They can also be areas of high earthquake activity. So pause it for a second and think, why might an earthquake be happening at boundary lines where where two different sets of plates are pushing at each other? Why is there going to be an earthquake that happens from that? I want you guys to think about that. Pause it. And then when you're done thinking about it, unpause and continue with the rest. So now that you have thought about why earthquakes happen at these convergent boundary areas, why do you think that is? My personal thought is, like, if I were to take two sort of hard things and hit them together really hard, it might jostle some stuff. In other words, it might move some things. And that could potentially move the earth if two plates were hitting against each other. So let's go down to divergent boundaries and find out what those are. So divergent boundaries, a divergent boundary is one where two plates are getting pushed apart. So again, let me illustrate that. When we have plates getting pushed apart, we saw those on the map. The plate's moving that way, one plate, and the other plate is moving the other way. So they're not hitting against each other. So they're not shaking each other up. The area on the land where the boundary occurs is called a rift. New land is formed by magma pushing up from the mantle and cooling as it reaches the surface. So as these places pull apart, as they pull apart from each other, they were once connected, but now they're disconnected, which leaves room for things that we call rifts. Okay, rifts are where potentially there's an opening in the land and magma can flow out and kind of fill in the gaps that was left from the plates moving away from each other. And then that kind of cools and it actually becomes new land and things grow on it. So let's go down to transform boundaries. Transform boundaries. A transform boundary is one where two plates slide past each other. These places are often called faults and can be areas where earthquakes often occur. Let's look back at that map that I was showing you, and it's a place that kind of means a little bit something to us, and that's right over here at the coast of California and Baja California. And you see that this is a transform plate. These are transform boundary, excuse me. These are two different plates that are moving next to each other, sliding next to each other. And this area is called the fault, right? We just discussed that in the passage where it said the area where they are sliding against each other is actually known as the fault. And this particular fault is the San Andreas Fault, okay, which is responsible for the reason we feel some of the earthquakes that we feel. Let's go ahead and get out of this and back to continents. Oops, nope, we're not here. We are on interesting facts about plate tectonics. So what are some interesting facts? Well, one famous transfer boundary is the San Andreas Fault in California. Would you look at that? See what it shows us. There we go. There's California. There's us. Nice. It is a boundary between the North American plate, we saw that in the map, and the Pacific plate. Okay? It causes so many earthquakes in California. We know that. We feel them. The Mariana Trench is the deepest part of the ocean. It is formed by a convergent boundary between the Pacific plate and the Mariana plate. The Pacific plate is being subducted under the Mariana plate. So that, again, we're looking at two plates literally hitting each other. They're hitting each other so hard that it's almost like they're playing chicken, and one goes down underneath the other one. So that is called the subduction area. Scientists are now able to track the movement of tectonic plates using GPS, which stands for Global Pinpointing System. The Himalayan mountains, including Mount Everest, were formed by the convergent boundaries of Indian plate and the Eurasian plate. So let's take a look at that on the map. The Indian plate and the Eurasian plate. Let's find the Indian plate and the Eurasian plate. Oh my goodness, they do have some serious convergent boundaries here. Let's take a look at that. We have the Indian plate pressing up against the Eurasian plate. And what they said is when these two things hit each other, I don't think they subducted. Instead, they hit each other so hard that they pushed rock up. So all the land pushing together, it was almost like you're taking foil, aluminum foil, and scrunching it. And what it did is it scrunched up Mount Everest, one of the highest mountains there is. So very interesting to see what that does to our environment, the different sort of plate boundaries, how we see those plate boundaries kind of fold out or unfold today. So that is all. If you did not fully get all of the main ideas, I would just stop and rewind and play each passage to get a better understanding of what it is.